traditional data handling or statistics, we are busy with mutually exclusive, exhaustive, complementary, independent, and all of those words means something you've got to know. So, as we're on lesson 100, okay, the homework was on page 348, number C, E, and I. Number C said, if A and B are independent, and they give you other stuff as well, what does independent mean?
When you type them together, they give
When you type what?
When you type them together, they give you A and B.
A and B. That's the most important thing. But you're going to just say it in the general. So I know that, let's see. I know that PA and B will equal
to PA times P.
the probability of each
Times
with each other. That's the product rule for independence. But it must be and.
Yes.
So you can't be confused and think it's or. So for the and, but now that's what I'm giving you by saying it's independent.
Yes.
What about the rest? Because they're asking me for all. So I think I'm busy going for the identity. But I've first got to work out the and, then I can use it. So the A times the B will be 0.3 times
0.6.
Excellent. Now this child didn't show it. I think it's not wise. Rather show me that you know. Therefore, PB is 0.6. You should get your mark over here for knowing PB. But it's better to be exact. Alright. Then this answer is?
0.18.
Alright. Calculator. Finding what they're asking me, the all part. That means PA plus PB minus
PA and B.
which I just found out. Now the and part only because they were independent is the product of the two. Do you see they're mixing up the two? But this is a lot of study work. Well, I mean, we're done with all the study work now. You know what you should know. So now when I say exhaustive, independent, complementary, you must know exactly what I'm talking about.
Yes, ma'am.
Alright, so substituting them in 0.3, it's a goal.
0.6
0.6,
minus 0.18.
and it gives me an answer of?
0.72.
Alright, answer for PA or B. You don't have to rewrite it because I see sometimes kids have a problem with that. That's the answer. Done. But you had to go find the and part first using the fact that they are independent, otherwise you didn't have an and part to put in there. For independent events again, finding just B, but they're giving me the or.
Yeah.
Okay. So what do we know about independence? The and is going to be
PA times PB.
if you have that, do you think you've got marks? Yeah. Definitely for the sum, knowing the independence means this, you've got a mark. Problem, because I now don't have and, so obviously I'm looking for it just like over there. I have or. I have B, but I don't have A.
Yes.
Suggestions, because now we're starting to look at not just the level 1 sums, knowing the facts, knowing the formulas, knowing the rules, something different. If you're thinking about the or part,
Can you use
we know it's going to be PA, which I have no problem with, it's going to be 0.6, right?
yes.
PB,
It's gonna
that's the
be
one I'm looking for,
yes, plus PB.
okay? The or part, I have, but I'm short
And
the and part. And the and part,
you don't.
I know something but not enough.
So you can use the PA times PB for this. But then you have PB.
Okay, but then what is PB? Can you just substitute it in here?
Yeah.
So in other words, do you agree? Knowing it from there, I can substitute in there, so I think I would have left the substitution for the next step, but that's okay. You don't have to do it all together. This is still going to stay 0.76. If you wanted to take that across already, you could have 0.6 PB minus PA was
0.6
times with PB.
Yes.
So what's happening here?
Like two.
Solve for PB. So these are what terms?
Like two.
Like terms. You see it, it's like x minus 0.6 x will give you how much?
0.4.
Are you with me? Solving like a x. And if you wanted to, you could have said from the start, "Oh, I don't know what PB is, let's make it x. Let's make it x. Let's make it x." So over here you had your x. Different techniques. And 0.6 is still there, 0.76. If you wanted to take it across already, you could have and said that becomes
16.
and then to find your answer,
Divide
by
0.4.
0.4. And how much is that?
0.4.
Probability of B. The question was find the probability of B, just make sure. That's why I taught you, when you're inside a question, highlight the question. What was the question? PB. Did I find PB? Yes, I did. So maybe over here you were trying to find something, you already got an answer, you think, oh, I've got an answer, so I'm finished. No, you're not. The question was find A or B. Once you found A or B, you can highlight and say, yes, I'm done with my sum. Highlight the question, highlight the answer, then you know you've answered the question.
Yes.
Okay, number I, C. Probability of A is given, probability of B is given. Note that I don't know what the circumstances are here. It could be something that I can actually wrap my mind around. Probability of raining or not raining, probability of wearing this type of dress or this type of shoes, whatever the case may be, probabilities. This I don't know. The question says, I give you probability A and B, and I say that you must find the and part. So I was thinking Venn diagrams, I'm thinking that's where they intersect. Find the and part if I tell you that they are independent. What do you know?
You times them together.
PA and B, that's where you multiply. PA and PB. Straightforward, so it's 0.8 times 0.6, and the answer is?
0.48.
That's it. How many marks?
3.
3, maybe even just 2. Knowing the formula substitution answer, maybe 3, maybe 2. But now, please find me A and B if A and B are exhaustive. See, all the rules, what goes where. If A and B are exhaustive, what do you know?
Or is equal. Equals to 1.
Somewhere you've got to get a mark for knowing that. So how will I find and then? In the identity, I hear it, thank you. So finding the and part, I'll use the identity, in which I now know that or is equal to
1.
That's where you're getting your mark, knowing that it's 1. The rest of them, 0.8, 0.6,
minus
and then minus the one that you're looking for. Please remember that you can shuffle the identity, it's an equation. So I can just as easily put that in the front there and say A and B would be equal to. Are you with me? In any case, you can swap the PA or B with the PA and B right from the start if you want to. But I'd like you to know the formula, then you can shuffle as you need it. So the answer, please, is? If I made a mistake and my answer was 1,2, would you feel uneasy? I hope so. Because remember that probabilities is less than 1, because it's actually percentages.
Yes.
So this percentage, the chances of A and B, whatever they are, happening together is 40%. Can't be 1,2, which means 120%. Can't be. All right, one more example before I give you 2 to go and try for or 1 to go and try for yourself. Careful how the question is asked. The question says, if I give you probability of A and I give you probability of not B, immediately you're going to tell me, okay, Vanessa,
0.7.
the probability of B is 0.7 because we call them what? Complementary events. It's either it is B or it's not B. So the chances for being B is 0.7, so not being B is 0.7. 3. Alright? Add up to 1. And the and part is also given. Now the question says, and it can be asked in various ways, are the two events independent, or prove that they are, or prove whether they are or not? Are you with me?
Yes, ma'am.
It's still about the independence, right? It's still about that formula. So eventually what I want is that formula must work. The or one must be, or is it the or or is it the and? Okay, please make sure, because if you start off with the wrong thing, it's going to not work. So if it's and, PA and B must be equal to
Times together.
the product, right? So if they are independent, this happens. What am I asking? Are they? You got to prove it. How do I prove that? This must take you back to tree. Left hand side, right hand side. Prove this identity. Prove this identity. So what are you going to have to prove?
You're gonna like use the identity.
Now pre A and B has not been given. Are you with me?
Yes.
So I'm going to have to find the A.
Use the identity.
Then I'm going to have to go and look if P, A and B, I can do that. I can do the A and B part, and I can find out that that is 0.5 times 0.7 and get an answer. But I have to find the AND part and see if it also is the same answer. So I can't do it like an equation. I've got to prove at the end, yes they are or no they're not. Because if it's not, then they're not independent.
Yes, ma'am.
We'll talk about that just now. But fact is, I'm aiming for this and I don't have AND. So how am I going to find AND?
Use the identity.
Identity. Identity, identity, identity. I think you know it by now.
Yes, ma'am.
Okay, so to find the AND part, the OR part would be, or can I swap it this time?
Yes.
So it'll be PA, that is 0.5, PB, 0.7, please don't forget you must use the 0.7, and then this will be the OR part, which is minus 0.8. Can I not write it from the start? So I have manipulated my identity from the start, and that's fine. Okay? Substitution, and the AND part that is equal to? Right, so if I look at this answer and I say, but listen, left hand side is the AND part, and that is equal to 0.4. Are you thinking back when I taught you in trigonometry? If I say prove it is, you cannot say it is. You cannot start here. You've got to look at the left hand side and look at the right hand side. In trig, with those identities, we had huge sums to go do. There's not so much to do here, but it's the same principle. Look at the left, look at the right hand side, which should be the multiplication. And what is the multiplication of 0.5 times 0.7?
0.35.
What do you see?
They're not the
They're not the same. Rounded off they are, but now remember, probabilities are only between 0 and 1. So are these different?
No.
For sure they are different. This is 35% chance and this is 40% chance. So it does matter in proving independence that they must be exactly the same. The rule says if they are independent, they are exactly the same. So what would this child have said? Left hand side, right hand side. So what am I seeing?
They're not equal, independent.
They're not. So they are
Not.
Can I not say dependent then? Independent. Think about this. Language, English. Antonym of being independent is dependent. That is not the case with this word. Dependency is something completely different. You are dependent from your parents to give you food every day. Are you with me?
Yes, ma'am.
But if two events are independent, the opposite of that doesn't mean that they are independent. We are testing for being independent, and we are saying they are not independent. And if your language English brain wants to say dependent, it's wrong. If you write dependent, that means something completely different. It means the one is actually waiting for the other one to happen so that it can happen. And that's not what dependency is and independency is. Okay? So the sum would have looked exactly the same if it was equal, but then this had to be 0,35 and 0,35, or whatever the case may be, but they must be exact. Because we do feel like 0,4 is close enough. So there might be a measure of independent, no, it's either independent or it's not independent. Okay. Okay. Same sum. Probability of x is given, probability of y is given, the or is given, but the question is determine, and I wrote a long sum out here so that you can see how it gets asked. Determine with reasons or prove with calculations, but you must give reasons, you must show how you got there. Determine whether x and y are independent. What are they testing? Whether you know that?
P is
Equal to?
the product.
So again, like in the previous, it would have been so much easier if they gave me the n.
Yes.
Then it was chop chop. The and answer was given, time the two and see if it's the same, done.
Yes.
Okay? But to find the and, you've got to first go to
The identity.
A and B. Now, A and B is not going to work for me, right? See what I'm doing? I'm changing the identity a little bit around. Please don't get confused. Are you with me? Please don't get confused if I do that. I want you to know the identity as all equals and the minus the A. Right. Now if I've done that, oh, I see. So if I substitute the x there, answer here. 36. Right, so if I know the n part, that would be my left hand side. Now I'm writing a little bit different than the other time. Are you with me? It's fine. Left hand side, right hand side then would be take the actual px and time it with the py. And I know that it wasn't even not straightforward. 0,5 times 0,3 and it gives me
0.15.
which means.
The left hand side is not equal to it.
So that's why x and y
I'm
not independent. Independent. It's a long word. I missed myself somewhere along the line. Does it mean I've done two now that are not independent, that they're always going to be not independent? No. Then we'll just make sure that those values are such that they do work out to exactly the same thing. All right. Venn diagrams. We're still busy with the same exact work, but now it's just working with Venn diagrams. When I ask you for it, could you have done this with Venn diagrams? Yep. It's always a tool. Sometimes it's a better tool, sometimes it's not so good. So you've got to decide from sum to sum. Now the question says, I'm doing exercise 3 on page 351. I'm doing number F. Number F says, A and B are two independent events. Immediately what do you know?
when you times them together.
What was our time together?
P. The two events.
If they are independent events, what should this be?
And N.
Right? Independent events is?
PA times PB.
So I'm just reading the first sentence and that's what I know. Independent events. And the PA was 0,3. Oops, so no, I'm wrong. PA is 0,2. I'm reading on the wrong place. And PA and B are equal to 0,08. So that one is given. But that's all that's given, and they say, please draw me a Venn diagram. Okay, that's not the exact question. The first one, what is all? What is not A and B? What is A not B? if you use a Venn diagram, it's going to be so much better for yourself. So this is what the whole exercise is about, taking the information and putting it in a Venn diagram. Whether they ask it or not, this exercise is all about putting it into Venn diagrams. Alright, so if I have to go put this in a Venn diagram, I don't know if I've got enough space there, but I'll go on there. A and B. Do you think I can have an intersection? Definitely, because they're talking about it. It's not 0. Okay? And if A and B is all that they're talking about, that's my situation here. That would be my whole sample space. Okay? A, I've been given is 0, 2. That's where I put it because that includes the intersection as well. The intersection, which is 0, 0, 8. Makes sense? What must be here?
0,12.
Because it must add up to 0, 2. Take your calculator. 0, 2 minus that gives you this. I am searching for, first question, what is the probability of A or B?
Find B first.
So I need B. So I know what this is. How do I always do the or part in a Venn diagram? That plus that plus that is the or. So if I knew what this was, I could give them the or answer. Can I not still go for my formula?
You can.
The identity. Please help me.
And then you can use the A, that's the product one, because you have the and you have A.
Excellent. So the and one should be P A times P B must also equal the 0, 0, 8. It goes with this as a whole section on its own. So that is 0, 2 times with the probability of B gives me 0, 0, 8. Because you can't just add them all together and say it must be 1. That would have been the case if A and B were exhaustive. Then I could have gotten this one by saying, what do I need to get to? 1. But I don't know what's going on the outside here, so I can't assume that. So the probability then would be of B equal to?
0,4.
Now, if probability of B is 0,4, then I'll go here and say 0,4, meaning that this will be?
0,32.
Because I have to add them up to get to 0,4. What's hanging about on the outside? Add them together. It's not 0,6. It's 0,52. So I'm short 48 on the outside. That's my Venn diagram. Now the questions are, what is the probability of A or B? Could I have done it with the formula?
Yes.
Okay. But if I just have the Venn diagram, it makes my life much easier. Because the or part is plus, plus, plus. I already said that that answer was 0,5. So you just add them together. Are you seeing this?
Yes.
The B part asks, what is the probability of not A and B? Be careful. They didn't use the little accent there. They said not A and B. What are they asking? It mustn't be in A,
But it must be.
but it must be in B. Not A as well as in B. Now listen carefully. Where is not A? Where is not A? Everything outside of A is what? Both of them are not A. Probability of not A, where's not A? That's not A. Where is B? There's B. But I'm looking for the and.
So,
I'm looking for the intersection of not A,
so it's 0,32.
but also B. Where's the intersection?
0,32.
The 32.
Yes.
Look again. Not A, look at my hands. Not A is, that's A. So not A is there. Where's B?
It's a circle.
And I'm looking for the
Intersection.
intersection of those two things I've just shown you. The not A and the B intersect at. So So I'm not doing any sums here. I'm just using my Venn diagram. My hands. Number C. What is the probability of A or, so I'm really trying to find out whether you can be. So or means what do? Add all the stuff together. But now what stuff? A
and not
which is that? Not B is where?
so 0.12.
Are you with me? So if it's A, there's the whole of A. The not B, do you count things twice? So where's A? That's the 0.2. Right? And where's the not B? There and there, but you counted this already. So it means that it's this all added together. Good idea in an exam is to show them what you've done. That I said 0.12 plus 0.08 plus 0.48, so that the marker, if this was a mess, and you had 0.4 and 0.3 and 0, whatever other stuff, but over here I can see you did what you should have done. It's those two and that thing that you must add here. It's easy to give you the marks. If you just give me an answer, it's difficult to go find it, and markers in grade 12 don't always want to go and search for it. Which gives you an answer of 68. Okay, now listen. Or add them all together, but you don't count something twice. And is where they intersect. But if you're looking for not A means those two. The B part means those two. Where do they intersect? Because that's and, intersection. This one was all, so you add them all together. The whole of A and everything that's not B. Everything that's not B is those two. But then I'm not going to count that twice. So it's just those three added together. Okay, tricky. Okay, you're going to try that. Similar to this, so you're going to be drawing the Venn diagrams with the ABC, and we're still really talking about exhaustive, exclusive, independent, complementary, whatever, and then you're going to know what it means for me. If this had been exhaustive, then that had to add up to 1. Then I would have figured it out by saying, what do I short for 1?